Hi friends, welcome to follow up. Let's have a look at problem 2780, minimum index of a valid split. In this video, we're going to explain a solution based on count and check. So here, this problem mainly about the dominant element in a list. So here, an element x of an integer array of length m is dominant if the frequency of this element is basically larger than half of the length. So more rigorously, so frequency times 2, this is the integer, right, is greater than the length. So due to this definition, actually, if there were a dominant element, so this element must be unique, right? So if you have 2, then the 2 frequency summed up will be larger than the length. That's impossible. So we are given a zero index integer array called nums of length n with one dominant element. So this is our assumption, right? So we want to find a split index I such that, so from index 0 ending at index I, and this is a sub array, right? Then from index I plus 1 up to the last index, this is another one. And then this split is valid at index I if, the two non-empty subarrays have the same dominant element. So here the requirement for this problem is to return the minimum index of a valid split. If no valid split exists, we're going to return -1. So here there are 3 examples. So we're going to focus on example 3 later. So for the first example, so 2 is the dominant element because it appears 3 times. So 3 times 2 is greater than 4, right? And then we can see that if we split at index 2, so we're going to have 2 as the dominant element for 1 to 2, and 2 has as a dominant for the single element list 2, right? So this is the output. So in the second example, so I guess here 1 appears, let's see, 6 times. So 6 times 2 is 12. 12 is larger than the length, right? This here is 10. And then the split at index 4. So this 0, 1, 2, 3, 4. So we're going to have 1 appears 3 times in the first half. So it's going to be the dominant element. Similarly, we have 1 appears 3 times in the second half. So it's a dominant element. So in the third example, as a whole list, so 3 is dominant element. Its frequency is 4, and 4 times 2 is 8, greater than 7. However, if we check every element, every index, so split into 2 non-empty parts, so so 3 cannot be the common dominant element. So here actually there are some simple reasoning we're going to explain, right? So notice that the return for this one is -1. So though it as a whole list, it has a dominant element. The constraint for this problem are the following. The first one is a length, right? The length can be as long as 10 to the power 5. So this number is large enough or decent large. The second element, the second one is on the range of the elements in the list. And the third one is the assumption. It says that there is exactly 1 dominant element in the whole array. So with that said, basically we are ready to do the analysis. So here for this problem, once we notice one observation, and then the problem is actually straightforward. So our strategy will be count and check. So we are going to find the dominant element and its frequency, and then we do a linear scan to find the index if there is valid split. So the observation is the following. So if x with frequency f is the dominant element of the whole array of length n, here you can think of this array as nums, then the frequency times 2 is greater than n, and therefore this element x must be unique, right? This by unique we mean the dominant element is unique, right? So the dominant element element must be unique. So if there were valid splits, and then the common dominant elements has to be and the X, right? The dominant element in the whole array. So the reason is very simple. The reasoning. So assume that the common element, the common dominant element is Y for the two subarrays of length n1 and n2. So for sure n1 plus n2 is the whole length n. So we assume that the element has frequency f1 in the first half and f2 in the second half. So because this Y is the dominant elements in the two sublist, so we're going to have f1 times 2 is greater than the length n1. Similarly for f2, right? And then if we add them together, so we're going to have f1 plus f2 times 2 is greater than n1 plus n2, which is nothing but n. So f1 plus f2 is nothing but the whole frequency in the whole array, right? So in other words, Y dominates in the whole array, right? So as we know, the dominant element in the whole array is X and is unique, so we must have Y equals X. Therefore, for this problem, the idea would be first find the dominant element, and then we are going to do a linear scan for the index, and then we want to check in the first part of the array ending at the index I, and the second half ending before after index I, to see if X or the dominant element in the whole array can dominate in both halves. If so, we're going to return the index and the break or return. So otherwise, there's no, right? We're going to return -1. So this is our strategy. So now let's look at the coding. For the coding, first I'm going to get n, right? So this is for convenience, or to make this idea clear. So first we can use a counter, right? Collections counter. So we use this. This will give us the unique elements and their frequencies. So we want to find the largest frequency actually, right? So here we can use a max function, or we can use a for loop. So here the element and the frequency, right? The total frequency. So I'm going to set it to be 0, 0. So here set element to be 0 because the range is greater than or equal to 1, right? And then you can also set it to be none, right? Then you can just reset. So here let's do the iteration. So for this key and values in the items, then if v is times 2 is greater than n, so we're going to set element and the frequency to be key in the v, and then we break, right? As long as we find the dominant element, we break. And next, we're going to find the split points. So this first part, let's see, find the dominant element and its frequency. So here we should see the dominant element. And then the second part, find valid split point if there were. So for this, we can start from index 0. So here actually we can think of, we split the array to be two parts, right? I plus 1 and then ending at n minus 1, right? So one is from beginning and ending at index I, and the other is the remaining parts. So for this, we can count the current frequency of this dominant element in the first half, and then the frequency in the second half will be nothing but the total frequency minus this current frequency, right, during our traversal or linear scan. So well, I is less than n minus 1. So here we want to make sure the second one is not empty, right? If I equals n minus 1, so ending at n minus 1 means the whole array. So the second one will be empty, which is not good. So here, let's say if nums I equals element. If this is the case, so we're going to increment the frequency by 1, right? And then what we are going to do, we want to check if this is a valid split point. So what makes it a valid split point? First is that the current frequency f times 2. So this is the first, the frequency times 2 should be larger than the length, right? The length ending at index I would be I plus 1, right? Because this element is included. And also we want the second one is also dominant. So the frequency, the total frequency minus current frequency times 2 is greater than the total length minus I plus 1, right? So this second part is very important, right? You can think of this example. If you do not do this part, then you're going to return a wrong result for that example. So here, if so, we are going to return I. So after this check, we are going to increment this I. So otherwise, if nothing has returned, we are going to return -1. So this forms a solution format to this easy problem. So now let's look at a test. Yeah, it passes this special example. As I mentioned, so if you do not have this second add, let's copy this part. Let's first do a full test. Let's see. Yeah, it passes all the examples. So here, let me mention that if we just check one and without the second part, so let's see. Let's comment out this first part, and then let's delete this one. Then for this example, so this is going to return 0. The reason is that for this one, 0 dominates, right? If 3 dominates, so in other words, if the array contains only one element, that element dominates, right? So let's move this one and return this back, right? So this will pass all the same. So with that said, basically that's about it for this problem, and also it's the end of this video. Thank you.